Dear students, so far we have discussed about the different types of implements which are connected to the tractor. You have also seen the operation of these into the field, and in the course of the lectures I have discussed about what are the forces which are coming on to the tractor with respect to the soil and its operation. Now, we would like to clarify certain other things. You might have seen that we talked of the weight transfer in the class. I would like to explain more in details at this juncture, and also I would like to tell you that how we get maximum power from the tractor. Actually, it is because of the tractor wheel, whether we are talking of the front wheel or the rear wheels. When in case of a front two-wheel drive, we are talking with respect to only the rear wheels. When we talk of the front four-wheel drive, we talk of all the four wheels in which power is given. Now, let us have a look at what it is when the condition of the tractor is a simple static condition. I have already explained this, but I would like to draw your attention at this point that in the static condition, we do have the weight of the tractor over here, then the reaction of the front and reaction of the rear. Now, here I have just shown a force PV here. Now, in case of a static situation, we have this PV is equal to 0. So, when this is 0, what we get is we get simply WT, which is equal to RR plus RF. Now, the moment we have this value, when PV is greater than 0 and it had certain value, what will happen? There will be change in this, and in that case then the value, this particular RR will not be acting. It will be acting at some other location. I will just give you an example. See, it will act at slightly angle at this point with respect to the rear wheel, and at this point in case of the front wheel. Now, coming back to this. So, what will happen is the moment there is a change in this, because of this PV greater than 0, we will have a weight transfer. So, what is the amount of that weight transfer? Well, before we go into the details, I would like to tell you what are the factors on which these weight transfer depends. See, it depends on the magnitude of PV, that is the value of PV which is there, then the distance height of hitch, at what point we have hitched, whether at this location or at this location which has been shown. This is the height y or this is height y here. So, where we have hitched, this is very important. Then the angle of pull or the angle at which it is hitched. Now, we know that line of pull, because line of pull is the line where, if we consider somewhere here is the center of resistance of the implement, then this is the hitch point, although in case of a 3-point linkage hitch, this will go somewhere else. But I have told you in the class that this can come below the transmission, somewhere below the transmission. We would like to assume here, not the virtual hitch point. So, the line joining the CR and the hitch point is the line of pull. So, at this line of pull, if this is the force PV, then the horizontal component of this, which is PV cos theta, will be the draft which we say, and PV sin theta will act here at this point. Now, so it is very important that this angle is to be taken care of with respect to the implement, and this will vary depending on the type of the implement which has been attached to this. Shift of point C, of course, depending on the soil condition and depending on the speed of operation, etc. This value, this point C, actually a point C is here as I showed here. Initially, in case of a static, this is C is not here, C is not any other place, but it is exactly below the center line of this. But the moment there will be a load transfer, it will shift to this place, which has been shown in this particular figure over here. So, this load transfer will depend on these. Now, let us have some notations which I have given in this. PV is the pull of the implement. Why V we have written? Because these all we are considering in the vertical plane. So, PV talks with the pull of the implement in the vertical plane, theta is the angle as I told you earlier, then Hg is the gross traction force. This Hg force is shown over here in this diagram. Hg is the gross traction force, because the moment PV is greater than 0, we will assume this condition of the tractor and not the static condition. This becomes the dynamic condition here. This is the dynamic condition, and in that case this will come into play. Then RR, rolling resistance of the rear wheels. We will see here rolling resistance of the rear wheel, similarly rolling resistance of the front wheel, then the rolling reaction of the force on the wheels, see reaction force on the rear wheel. This is the reaction force R in the rear wheel, this is the reaction force on the front wheel, which was in case of a static, it was simply RF and RR which we have taken, and I said that in case of a static situation, we have simply WT is equal to RF plus RR, this. So, and RR is the rolling radius. This is important. I had also to discuss this in the class, but it is important to show to tell you and to show also in the actual situation I will show you. Zero load condition. See, rolling radius of the tractor tire is in fact when you have a zero load condition, that means there is no load on the wheel. So, there the distance travelled in one revolution. If the wheel is travelled for one revolution, then the total distance covered divided by twice pi under zero load condition is the definition of rolling radius. It is very important. One must consider this in the analysis of the mechanics of these forces when we are considering a tractor and implement combination. VA is represented the speed of the forward travel. Well, we have talked of this here, or we are talking of here when the movement is in this direction. Similarly, when we consider this is a towed wheel in the front of the tractor is a towed wheel in case of a two-wheel drive. Mind you, this is a towed wheel where we have this force only which is pulling it, and then this is a powered wheel. In case of a powered wheel, this is the situation here, that we have a torque which is acting, weight of the implement is definitely acting here, and this pull at the same time that this gross tractive force and the soil reaction force G which is here. Now, we can see the details of this particular. G is the resultant force of Hg and Fb here, Ta is the torque which is onto the wheel, then W omega is the angular speed of the wheel. This is the angular speed of the wheel which has been shown over here. PV is the vertical component of the soil force. This is the vertical component of the soil force which is shown over here. Then ER and EF, as I have told you here, EF and ER, these are the eccentricities in the front and rear. CG is the center of gravity of the tractor, in fact tractor chassis that we call it at both the locations which I have shown here as well as this location here. Weight of the tractor WT which is shown already. L is the wheel base. Well, this is the distance which is known as wheel base. I have already explained at several locations. Again I describe here that this is the distance wheel base when we are talking with respect to the center distance between this wheel and center distance between the rear wheel. So, center to center distance between the two wheels, the front and rear, is the wheel base. So, this is what is given here. The wheel base XCG is the distance of CG from the rear wheels. This is the distance which we have got here, XCG. This XCG here, which is the distance of CG from the center of the rear wheel, XCG is this. Then RR dash, RF dash, or in fact when it goes into the soil, definitely this RR will not be at the center line of the wheel, but it will be at certain angle. RR dash in case of rear wheel and RF dash in case of front wheel. So, and that is why we get these eccentricities which I talked of earlier, CF for front and CR for the rear wheel. The weight of the front wheel, well, weight of the front, definitely weight will be there, whether weight of the front wheel or even weight coming on to the individual wheel, which is described here. Towed force, yes, this pulling force, because when there is this tire, the front one in case of a two-wheel drive is a towed force, simple force is there, there is no torque. We have also discussed, you may recall that I have discussed about the different types of tires. For example, the towed wheel, I have discussed about a self-propelled wheel, I have discussed about a powered wheel, braked wheel, etc. We have discussed and I have shown you the instances as well as I have given example of where they are. So, when we are talking of this weight transfer, as I said, I will come back to this. That means, we have weight transfer from the front, because the moment PV is equal to 0, what happens that this RF starts decreasing. Now, when RF starts decreasing, that means there will be there may not be a physical change, but definitely there will be a load, or there will be a transfer of load from this side to this side. That means, from the front of the tractor to the rear, and this value is given by, if you take moment about this point, then the value is given by this. This is the dynamic weight transfer to rear wheel. This is the one which is from the front wheel. So, in case of this is the amount which is transferred from the front wheel to the rear wheel. By this dotted line, we are just showing you just an idea that how this takes place. Physically, it does not take place, mind you. Keep always remember that there is no physical change, but yes, actually it takes place, and you see it how, because when the tractor gets overturned, you will know that definitely it has happened. Lot of load is here and this has happened. So, on that count, we would like to tell you what is this weight transfer. So, the dynamic weight transfer of the rear onto the rear wheel to the rear wheel is this amount P cos theta into y, which is this. When you take moment about this point, this equation comes. So, ER into RR and L minus R, because L is the total distance and minus this, because we have taken moment about this point here, minus F. So, total dynamic weight transfer to the rear wheel is then PV sin theta, because this is, if PV is the force which is acting in this line, as I showed here also, that PV cos theta is the draft which is acting in the horizontal direction, and then PV sin theta acting downwards. Now, this is the force which is because of the implement, because of the implement which is connected here. So, the total force will then come about this, which is because of the front wheels and which is because of the implement. For dynamic weight transfer to the wheel, to the rear wheels, this is because of the front wheels, and this is because of the implement. So, PV sin theta because of the implement. So, because of the implement, this and this, and add together, we get the direct total weight transfer. Now, this is very important to understand, because ultimately the tractors, this tire in case of a two-wheel drive or in case of a four-wheel drive, is the one which gives us the total pulling ability of the tractor. Now, let us have a look at the tire. What are those features of the tire which actually make this pulling ability enough, or pulling ability capacity of this? And many tractor manufacturers have manufactured different types of tires, and those tires with different types of their features, which we will see into the tire actually now, and on the basis of which they also try to see that what type of tire, what specification of a particular tire will be fitted for a 60 horsepower tractor or a 75 horsepower tractor or a given tractor. So, let us have a look at the tires. Well, as I told you about the tire. Now, look, this is tractor tire, rear tire. You have a look at this mark which is given on to that. This is in fact the specification of this particular tire, 13.6 into 28. Now, this means 13.6, as I have already explained in the class as well as in the field, that this talks of the section height or the section width. Many a times we take same section height and section width same, which is 13.6 in inches, mind you, and the 28 is the rim diameter, 28 inches in the rim diameter. Now, if you want to find out the diameter of the wheel, then we will have this 28 plus 13.6 plus 13.6. This we have been taking as a thumb rule. We ignore that up to a 20% delta by h, which I have told you the section height. So, on that count, we can take under normal pressure of delta by h is equal to 0.2, we can say that the diameter of the tire will be 28 inches plus 13.6 inches plus 13.6 inches. Now, in some of the tractor tires, there is a value, R is written. Can I write? R is written along with this. Now, the moment you see this, you must know that this is a radial tire. Of course, I have explained to you that what is the difference between radial tire and a bias tire, but from outside, if you want to understand, you must just look for this number R, which will talk that this is a radial tire. Now, what are the important features which actually help this particular wheel to generate so much of traction? It are these factors. Yeah, these are these self-clearing lugs, because when it goes into the soil must also come out. Otherwise, this will be filled up with soil, and then this will not be in a position to pull. In fact, it will start slipping, which I have talked of in the course of my lecture itself. So, we will just see these lugs or of different types in different tractors. It is based on the manufacturer, what the manufacturer wants. I will also show you different lugs and their sizes, but let us have a look at this particular one. The total length of this is this length of this, then the width of this, and the depth is or height of the lug is this. We can have a look at this value, what exactly we mean by this. I will show you. So, if we just put this, so this is the height, this is the height of the, so this is the height of the lug. Now, this height, the length and the various features which are there are the actual designs of the tractor manufacturers, and they claim their tractor's ability or the wheels ability on the basis of this, and lot of work has been done on the lug design, lug shape, features and this capability, etc. Now, we would like to tell you how we are in a position to tell what is the capacity of a particular tire, how much load it can take, and to which particular tractor a given size of tire could be fitted. For this, we have a facility developed at the IIT Kharagpur. We call it traction laboratory. In this traction laboratory, we have a 80 feet bin. I will show you the bin here. Well, so as I said, we have developed a facility in IIT Kharagpur which we call as a traction laboratory, and it is a 80 feet traction laboratory total length, in which we can have any type of soil. In fact, we have tested soils or sandy soils which we have brought from Rajasthan, and in fact, you can test and you can keep any type of soil here, measure the strength of the soil. We have also developed the facility for measuring the strength of the soil. We can prepare the soil the way we want, and then we can test the capacity of a particular tractor tire into this. And this has been long work which we are doing for a long time, and we have tested several hundreds of tractor tires manufactured by different companies. Well, we will not go into details of those, but definitely I will tell you the procedure and which way and what parameters we actually measure, which way it helps us in actually deciding, because as an engineer you would definitely like to know what is the capacity and which type of tire to be fitted to which type of or what size of the tractor. So, for that we have the bin. I can show you the more details, or we have facility for the measurement of speed, we have facility for measurement of torque, we have facility for measurement of the sinkage, we have facility for measuring the soil strength depending upon, and then all these are automated, and directly when the tractor tire is being tested, we can measure the pull also, and then everything is recorded in the computer cell which is there, and we can find out the values at any moment of time. So, I will discuss and show you the details of this facility here for the knowledge, and then we will talk of some more details of how the loads are carried by the wheels. But before I take you there, I would also like to show you the different types of tires and their sizes of the lugs. It will be of importance to you. You can have this information, because this is not any secret information. As an engineer, you must have a look at it. As I explained there about the lugs, now have a look at the values of these lugs, in particular design of different types. We have shown you here different types of tires manufactured by different tractor tire manufacturers. We may not tell you about that, but we definitely want to impress upon you that have a look at the designs of these lugs. Have a look at the designs of these lugs which are given over here. Some of them are tires, bias ply, some of them are radial tires. Now, what are the details of these lugs? See, a bias ply tire will have these details, a radial ply will have these details, and these are the important parameters which help the tire to have a higher and higher grip onto the soil. Now, it is a different question that what will happen in which type of soil, which needs to be investigated, and lot of work has been going on in this respect. But then manufacturers would always like to know what is the capability of my tire, whether this tire or any tire, what is the capability of this. So, by a thumb rule, what we do, if this is the total weight of individual tire here and the power, that means power of the engine, if you know the power of the engine and we want to know what is the capacity of our tire, of the manufacturer's tire, then by a simple rule of weight to power ratio, this is the weight of the tire and this is the engine. If designated in kg, this defined in kilowatt. So, the value, if this value falls somewhere between 68 to 78, we can find that yes, the tire can be used. But then there is definitely requirement of what is the actual print of this tire when it goes into the soil, and that is more important. And for that we need to find out the tractive efficiency of this that particular tire with the different types of lugs which we had. So, tractive efficiency, this is given as drawbar power by axle power, P axle. Axle means the tractor's axle power. Now, this value vary between 65 to 70%. We need to look into, if the value of tractive efficiency comes somewhere here, we may say that yes, the tractor tire is in a position to be fitted to a given tractor size, that means the horsepower of that. But then for testing under the conditions which I said, under traction conditions, under varying soil conditions, varying compaction conditions of the soil, which I will show in the actual working, what we need is, we need to know what is the actual velocity of the wheel when it moves, what is the theoretical velocity of the wheel when it moves, and how much is the torque that is being applied onto the wheel when there is a certain weight on that, what is the torque which comes when it is being pulled through a certain pull force. So, with these parameters we need to measure these under the laboratory conditions, and on the basis of that we will know what is the print, because we will then be in a position to find out. For example, if I get some space here, I will show you the general this could be the general print of a tire. Maybe that I will show you what exactly is the print of a tire, but then this is generally, we have found that this is a elliptical in shape. I have also told you in the class, I can show you a detailed one which we have tested. Maybe if I show here, this is what exactly is that this is the tire print of an actual tire. We will not disclose the other details, but I can tell you that so this is what it is. You can see the print which comes, and generally we measure this distance here as well as this distance, and we find that generally this is elliptical in shape, as I told earlier. So, if you want to find out the total load, this divided by 0.78 AB. So, this is the total pressure which is there onto this. Now, there is an important factor. When we do these exercises, definitely we must do at varying pressures of the tires. Generally, we start from, say, and we give in the rear ones a certain pressure of, say, it starts from 0.8 kg per centimeter square to 1.0 kg per centimeter square or 1.2 kg per centimeter square. Now, these are important parameters which we follow and then measure all these values to decide whether a particular tire is good and how much is the capability of that particular tire to be fitted in if it is fitted in a certain capacity of tractor. Let us have a look at the test facility which is there. So, you can see that, have a look at various types of tires which have come from various manufacturers, and the facility is unique, as I said. Now, I would like my students who have been involved for a long time in testing of this to explain more details about each and every component.
As described by the sir, that we have to measure the tractive efficiency and various other parameters to calculate the performance of tire. For calculating the actual speed, we are using a proximity sensor. By this proximity sensor, we calculate the actual speed of this setup, and for calculating the theoretical speed, we are mounting one more proximity sensor on the axle of this shaft, and by which we calculate the theoretical speed of this with this setup. And by knowing the actual and theoretical speed, we have to come the how much the slip is coming and other parameters for calculating tractive efficiency. For calculating the torque, we are using a torque sensor. This is a torque sensor by which we come to know how much torque is coming from this motor to this setup. For calculating the amount of pull, we are using this ring transducer. By this we come to know how much pull is coming on this setup.
As my friend explained you about the ring transducer to measure the pull. Now for measuring the tractive efficiency and the slip, that at which slip maximum tractive efficiency is achieved, for that we applied the known load or known pull on the tractor tires. For that we use the brake drum type dynamometer. This dynamometer used to apply the known pull on the tire. This is the device. With the help of these we applied the known load and we measure what is the tractive efficiency and the slip at the corresponding load.
Well, as per explained by Professor V.K. Tiwari and my friends about the soil traction laboratory of IIT Kharagpur, I am going to explain you about the processing trolley. By the help of this processing trolley, we are preparing the soil. We are preparing the soil of different strength level. For preparation of soil, this processing trolley consists of rotavator, leveler, cultivator and roller. By the help of this rotavator, we are tearing out the soil, and by the help of this leveler, we are leveling the soil inside this soil bin, and by the help of this roller, we are compacting the soil at different compaction level. And to know the compaction level of soil, we have made an instrumentation on this soil bin. By the help of cone penetrometer, we are measuring the strength of soil. This cone penetrometer is assisted with S-type load cell. There is a potentiometer. By the help of this potentiometer, we are measuring the penetration depth of soil.
Thank you.